Good afternoon, guys, and we have covered the first chapter of KAPLAN preclinical pharmacology, and today we are going to start the second chapter, which is known as pharmacodynamics. So let's start with the definition of pharmacodynamics. What is the term pharmacodynamics? It is the effect of drugs and the mechanism of the actions of the drug. Okay, in the pharmacokinetics we see the effect of body on the drug. It means that the absorption, distribution, elimination, administration, all of them are covered in the pharmacokinetic principles. But in pharmacodynamics we see the effect of drug on the body, the effects, the mechanism of action of the drugs, and all of that stuff is covered in the pharmacodynamics. There are some terminologies or must say definitions. First is the agonist. A drug is called as an agonist or a facilitator when it binds to the receptor and it stimulates a response. This the drug is the agonist drug. Okay, as you can see that when the agonist drug binds to the receptor, okay, it enhanced the cellular activity, it stimulates a response. In contrast, when a drug acts as an antagonist or inhibitor, okay, when it binds to the receptor, it is not associated with a response, it blocks the cellular activity. Okay, and one of the way by which antagonist can block the cellular activity is that preventing an agonist from binding to the receptor. When antagonist prevent agonist from binding the receptor, so how the cellular activity would be enhanced? No, it cannot. So in this way it can block or prevent the cellular activity or block the cellular activity. There are three important terminologies. This is just a brief introduction how pharmacodynamic principles are going to be shown in this chapter, but in the later videos we'll discuss in detail each of them. First is the affinity. What is affinity of the drug? It's the ability of the drug to bind to a receptor. Okay, and it is shown by the proximity of the curve towards the y-axis. Nearer the curve to the y-axis, the greater the affinity. Okay, if the curve is closer to the y-axis, it's just a law, you need to remember this, that affinity of the drug is the ability of it to bind to the receptor, and it's shown by the proximity of the curve towards the y-axis. The nearer the y-axis, the greater the affinity, but the condition here is that the curves are parallel. Like these, the curves are parallel, so the drug A has more affinity than the drug B, and affinity is inversely proportional to the dissociation constant. Dissociation constant is Kd. What is dissociation constant? It's the concentration of the drug at which 50% of the enzyme is bound to the drug. It's the dissociation constant in which the drug is 50% enzymatic bound, and affinity is inversely proportional to the Kd or dissociation constant. What is potency? Potency and efficacy are two important terminologies used in the pharmacodynamics. Potency is the strength of a drug at a particular dosage. It means that the amount of drug required to produce a 50% of the max effect. Okay, it means that the drug with higher potency, if we administered small amount of drug and they produce a maximum effect, it means that drug is highly potent. But the second drug, if we administered in large quantities but still it does not produce the maximum effect, the drug B would be less potent or it has the less potency. Let's see this graph. It means that the drug A has achieved the maximum maximum concentration at low dosage. Okay, this is the dose effect or dose response curve in which the drug A has achieved the max at low dosage. It means that the drug A is more potent as compared to the drug B. We administered a large amount of dose to achieve the maximum effect. So the drug B would be less potent. and it is also shown by the proximity of the curves to the y-axis. It's very important that nearer the curve to the y-axis, higher is the potency of that particular drug. What is efficacy? Efficacy is the maximum effect that a drug is going to have, maximum effect that can be achieved by a drug. After that point, higher dosage cannot produce any further effect. Efficacy is like the effectiveness of a drug. And how the efficacy is shown by the dose response curve? It is shown by the height. Okay, it is shown by the height of the curves. But efficacy, see the analogy to Vmax used in the pharmacokinetics. In pharmacokinetics, we uses the Vmax term to describe the like maximum velocity or maximum effect at which the drug is working, and efficacy is just as Vmax in pharmacodynamics when we used Vmax in the pharmacokinetics, and efficacy is analog to Vmax. So let's see this graph. It's also a dose response or drug response graph in which that a drug A is has higher efficacy than drug B, and lastly the drug C. Notice that these all drugs have the same amount. They are administered at the same dose. They have the same dose, but maximum effect is reached only by the drug A, then is achieved by drug B, then C and D has very low efficacy and higher efficacies by the drug A. And let's see this graph in which the affinity, potency and efficacy are shown simultaneously. So what is affinity? Affinity is the ability of the drug to bind to the receptor. What is potency? Potency is the strength of the drug at a particular dosage. And what is efficacy? Efficacy is the maximum effect a drug can be obtained or a drug can be achieved. So which one of the drug has higher potency? Either it's A or it's B or it's C. The more closer to the y-axis, the higher is the potency and potency and the affinity. So the drug A has higher potency and drug C has the higher potency. As you can see that these both are closer to the y-axis, and the drug B has less potency as compared to the drug C and drug A. Okay, and when we talk about the efficacy, efficacy is the maximum effect a drug achieve after which higher dosage cannot produce any further effect. It's the maximal height. So drug A and drug B has the high efficacy as compared to the drug C. It means that the drug B and A has the higher efficacy as compared to the C. It's like the um, maximum effect, and potency is like the maximum strength or the amount of the drug required to produce the 50% of the max effect. So this was for today, and I hope you understand these basic terminologies. In the second lecture we will discuss in detail about the dose response curves and all of that stuff. So I will see you in the next video. Till then, goodbye.